A simple random sample of size n equals 36 is obtained from a population with a mean of 76 and a standard deviation of 18. So first we want to describe the sampling distribution, so that's what part A is asking for. To apply these methods, the sampling distribution has to be approximately normal. That is going to be the case for this problem because the sample size is bigger than or equal to 30. In fact, it's 36. If this number is bigger than or equal to 30, we can assume this distribution is normal, and I'm going to choose A. To continue on this problem, we're going to use a normal distribution to eventually answer parts B, C, and D. But to do that, we need the mean and the standard deviation for the sampling distribution, and we can figure those out by looking at the mean and standard deviation of the original population. It is a fact that the mean of the original population and the sampling distribution, they will be the same, so you can merely copy down that number. Now the standard deviations won't be equal. To get this value, you take the standard deviation and you divide by the square root of the sample size. Whatever that number is, I'm going to put right here. I'm going to bring up a calculator to get that. You can use any calculator that you like. So again, that procedure is you take 18 and you divide by the square root of 36. So if you have this calculator on your phone, this is how you would enter it. You take 18 and click divide by. Now to divide by the square root of something, you first have to open parentheses, type in the number, 36 in this case, and hit square root, which gives you 6. And then you close parentheses to divide that number into the original one you entered, 18. So I'll click equals, and here I get my value of 3. This is the standard deviation for the sampling distribution. So I'll move this out of the way. I will choose 3, and I'll check my answer. Great. Okay, well, now that we have this mean and this standard deviation, what we can do is use the normal calculator that's within StatCrunch to figure out this probability. Here's what that looks like. I'll click on question help and I'll open up StatCrunch. Okay, I'll make the window just a little bit smaller here. To open up the calculator, you go Stat, Calculators, and select Normal. So we get this thing here. I'll enter in the mean, which is 76. I'll enter the new standard deviation, which is 3. And I want the probability that the mean of the sample size of 36 is greater than 80.5. It's the same if there's an equals, but I want to choose the greater than option. Enter in the value 80.5 and click compute. So this is the probability that we need to enter. It's, if I round to 4 decimal places, 0.0668. So about 6.7%, or roughly that. So the rest of these questions can again be answered just by going back to the StatCrunch calculator. So this one is the mean has to be less than or equal to, and the value we want to enter this time is 69.85. And if I get this probability, again rounding to 4 decimal places, is 0.020, and that's going to round to a 2. 0.0202. And this is the final part of the problem. Notice that there isn't just one inequality, but there's 2. In fact, the mean is between 2 numbers. The function in the calculator that's going to allow us to do this is if we select between. Again, the mean and standard deviation are the same, but the numbers I'm entering this time, well, there's 2 of them. I have 71.65, and I have 82.15. Okay, if I click compute, I can even see the graph of it up here, but this red area represents the probability between 71.65 and 82.15. Again, rounding to 4 decimal places, I get 0.906, and that 2 becomes a 3. So 0.9063. Okay, I'll check my answer. And that is everything that we need for this question.